Hello guys, what's up? I'm Engineer AK and today we are going to start the 7th lecture of chapter 2, metal structure and crystallization. So let's start. So what is hexagonal closed packed structure or HCP? It is a short form of hexagonal closed packed structure, right? So a closed packed structure, a closed packed hexagonal structure is a type of crystal structure that consists of layers of atom arranged in a hexagonal pattern. So if we see this one, this third diagram, or if we see the first diagram, so it is arranged something like that, right? So it is making a hexagonal kind of structure. Like if we see here, so here you can clearly see that this is in diagram third, it is making a hexagonal structure, and then arranged in a hexagonal pattern with layer stack arranged directly on the top of the previous one. So here we can see that it is first layer, then here it is another layer, and here it is another layer, right? So it is arranged in this manner, and the atom in each layer are arranged in a closed packed structure, meaning that each atom is in contact with its nearest neighbor. So like if we see in this diagram, so this is one atom and it is its neighboring atom, so it is attached with this, and its neighboring another atom is this, so it is also attached with this, it is also attached with this, it is also attached with this lower one. So the first layer is arranged in a hexagon, so here meaning that each atom is in contact with its nearest neighbor. And in this type of structure, the first layer is arranged in a hexagonal pattern, and the second layer is also arranged in a hexagonal pattern, but is offset from the first layer, resulting in a triangular arrangement of atom. So they are saying that here there are two layers. Like if I talk about this first layer, this one, and this second one, so they both are arranged in a hexagonal structure. Like if we see here, so this layer, right, and this lower one, so these both are a hexagonal structure and they are offset from the first layer, resulting in a triangular arrangement of atom, and they are separated by the triangular atoms here. And if I talk about this one, so here you can see there are three atoms that are so these two atoms are attached by this one, right? And the third layer is then arranged in the same pattern as the first layer, and the pattern repeats from there. And same like that, there will be again three atoms like this. This one, the blue one, there will be a blue one, then a green one, then a blue one, then a green one, and so on, right? And if we see the diagram, so this is the 3D model, right? And this is the unit structure. They have taken a unit of hexagonal closed packed structure, and this is the 2D model, that how they look, and this is the top view, right? So that there are this layer and this layer are arranged in a hexagonal structure, and then this middle one, this is represented by this green one, that they are making a triangle. Now how they are making a triangle, let me show you in this diagram, so you will understand it easily. So let me pick color. Okay, so let's suppose if I make a triangle, a hexagonal structure here, and then here, then here, then here, and then here, right? So now if you can see, so in this diagram there are making a, if you see here, it's making a triangle here, or you can say it is making a void. Void mean an empty space, right? Same if I see here, so again it is making a triangular void here, and same here, again it is making a triangular void, and same for here and here as well, and here. And let me color it a bit so it will be visible to you guys clearly, right? So there, so we can see these kind of triangles here. Now what they have done, that they have placed three, like in previous diagram we have seen that after hexagonal they have placed three atom over this this hexagonal structure, right? So what they have did, that they have placed one atom here like that, then they have leave this triangle, then again they have placed one atom here, then again this they have leave one triangle, and again they have placed another atom here. So in that way these three atoms are arranged here, right? And above these three atoms again there is another hexagonal structure. Hope you understand that. Now let me show you above in this diagram. Let me select a color. So here now you can see that this is a triangle, or let me pick another one, yellow one. Okay, so this is a triangle, not this one, green one. Okay, so this is a triangle, right? And there is a atom. Now this triangle is empty, right? This one. Now again in the next triangle, this one I'm talking about, let me change the color, this one, again they have placed one atom here, then again they have leave this triangle empty, then again they have placed one atom here, then again this is empty, right? So what they have did, that they have placed atom in one, then they have leave a triangle, then they again place an atom, then they leave then a void space here, then an atom, then a void space, then an atom, and so on. So this is how this structure is made, right? Now hope so you got the idea that what is the actual structure of the closed pack hexagonal structure, and how this triangle inside the unit cell is made. Now the second topic is coordination number. What is coordination number? The number of atom or ions immediately surrounding a central atom in a complex crystal or crystal. The HCP has a coordination number of 12. So now if we talk about the coordination number, that how it comes out to be 12. So as we discussed, that it is the that how much atom has surrounded the central atom, right? So here it is the central atom, And if we see though, so here we have 6, this is 3, 4. Okay, let me okay, so here 1, 2, 3, this one 3, 4, 5 and 6, right? So there are 6 atoms that has surrounded this this atom, right? This is the central atom over here, the yellow one. Now we can see that in there are 6 atoms, right? And below this this atom, here are 3 atoms, 1, 2 and 3, and you can also see here 1, 2 and 3. These are atoms are arranged to this one, right? So here are 3, and above it there will be also 3. Like first you will be having the hexagonal structure, then there will be 3 atoms, then again hexagon structure, then 3 atoms, then again hexagon structure, so and so on. So and this is there are 3 atoms below it and 3 atoms will be above it, so 3 and 3 6, and 6 are these, so it comes out to be 12, right? So that's the coordination number of close packed hexagonal structure is 12. Like this is the pattern that how the hexagonal structure is made. First hexagon, then 3 atom, then again hexagon, then 3 atom, then again hexagon, then 3 atom, then again hexagon, and so on, right? So this is the central atom. So this central atom is surrounded by 6 there, 3 below and 3 above, so it comes out to be 12. And this is the picture that I have taken from the book, and these are the lattice, right? And and the hexagon structure made like that. If I draw it, right, this is the one plane, and this is the central 3 atoms that I have discussed above, right? And this is the another plane about these 3 atoms. This is the another plane. So this is how it is made in lattice, or you can say if you want to draw the hexagonal structure in lattice structure, right? Now the number of atom in hexagonal close packed structure. So how many atom will be there in hexagonal structure? So let's discuss this. So if we see here, so there are 3 structure. One is this one, the one is this one, and the one is this one. And this is an atom, right? This is these are the corners, right? If I talk about, so these are the corners, right? So we are discussing the atom at the corner, right? So if I take this atom that will be placed here, so it will be shared by half, it will half shared by the 3 hexagonal structure above it and 3 below. So here in diagram second you can see that these 3 has divided the atom into half, mean half is taken by these 3 and the half is taken by the 3 structure above it, right? And if I divide now, if I this is half, and if I divide this half, mean if I separate this one and this one and this one, and let's suppose I'm taking this one, if I just take this unit structure, so it will be having a contribution of 1/3, mean we were having a one atom that is divided into two, and then that half is divided into three, so mean three parts of this half and three part of the other half, so it become total six. So mean that atom here having a contribution of 1 over 6, right? Like it has a contribution of 1 over 6 in this structure, right? So now if I talk about the corner atoms, so 1 over 6 and 1 over 6 atom contribution, right? And there was 6 atom, like if I take this one, so 1 2 3 4 5 and 6, so there were 6 atom, so it become if I cancel out these two, so it comes out to be 1, right? It comes out to be 1 over here. And we can see that one plane is this one and one is below, so it will also having the 6 atoms and having contribution of 1 over 6, right? So mean there are two planes, so I have multiplied 2, so it comes out to be 2 atom, mean this plane and this plane combinedly contain 2 atoms, right? And if we talk about the central atoms, so we have discussed before that there are 3 atom, one here, one here, one here, like I told you that they are making a triangle inside it. So these 3 atoms are not shared by any other atom because these 3 atoms lie inside this structure, right? So at center we have 3 atoms that I have mentioned here, right? Center atom 3. Now at faces, if we talk about the faces, let me go up here. So if we talk about these faces, so we can see that this face is half shared by this and the half is taken by the another structure above it, right? So half this one and half will be there below, so it will half and half, it become 1, right? So at faces we have total 1 atom. Now what will be the total number of atom? Corner atom plus center atom plus face atom, so it comes out to be the corner atoms were 2 and the center atom were 3 and 1 at face, so 2 3 and 1, it comes out to be 6, right? So we have total 6 atoms, and that's why it is called close packed, because in we have seen in FCC there were 4 atoms, right? In BCC there were 2 atoms, right? So and it contains 6, so I mean this is more closely packed as compared to the FCC, and BCC and FCC is more closely packed as compared to the BCC structure, right? So hope you enjoy the video and see you in next video. Thanks.